Now we will talk about method overloading. Let's say in a class we have a method that sum two integer values v1 and v2, and later on we are asked to write another method that is summing more than two items, let's say three items. That's why we need an argument list with three items v1, v2 and v3, and then we are asked to write another method for four variables, say v1, v2, v3 and 4, and so on and so on. When we are asked to write another method with the exact same operation or similar operation but with different arguments, we may use the same method name. Otherwise, we would need to find a different name for all the methods. Let's say this method's name would be sum two integers, this sum three integers, sum four integers. So this is not a reasonable solution. In this case, finding the correct method would be so hard. That's why we use method overloading. Method overloading means we may write multiple methods with same name but different input argument lists, and these methods are called as overloaded versions of each other. Let's write an overloaded method. Let's go to array operation, and we are asked to write another method to sum up all the double values inside a double array. So this is the same thing as we developed before, sum items. Okay, now we copy and pasted the same method, and compiler warns us duplicate methods sum items integer array in type array operation. It says you already developed this method, but if I change this int to double, compiler does not warn us because the input parameters have been changed. If input parameters number changes or the type of them changes in the method, in this case these two methods are overloaded versions of each other because they have the same access modifier, same return type and same name. The only difference is their input arguments. First one gets an integer array, second one gets double array. Now let's invoke some items with different versions. For differentiating the things, I need to put a sysout here to demonstrate you which method is being called. Int array is called, and let me write double array is called. Now I will invoke them on my first app, and here I will invoke the double array version of it. So I will duplicate the method here, double array, and it is basically storing some double items. That's all. Double my double array, new double, and inside two double items exist. Okay, let's invoke operation dot sum items with my double array. Now it will invoke the version that is getting a double array as input argument. Let's invoke it. Okay, now for the first invocation, int array is called, as you see. For the second, int array is called again, and for the third invocation, double array is called. So JVM is intelligent enough to select which version to use according to the input parameters. So that is method overloading. In this chapter we will talk about limitless arguments. Before delving into the details, let me show you the requirements. Let me create a class called a string operation, and inside it I will write a method that will concatenate multiple strings and return the concatenated string. Okay, let's say concatenate strings. This method will get two strings as input, and after concatenating them, return the result. So it will return s1 plus s2. As you know, a plus sign concatenates the strings, and string is simple text type. Okay, and we are asked to concatenate 3 strings now. That's why I need to write an overloaded version of concatenate strings. So let me put the third parameter here. So these two methods are overloaded versions of each other because their access modifiers, their return type, and their method names are same. The only difference is the number of their input arguments. This version will return s1 plus s2 plus s3. Now let's say we are asked to do that for 4 strings. I need to overload these for 4 parameters, and I'm adding s4 here. So when we ask to do that for 5 parameters, it will be not reasonable to go on like this. We are creating the overloaded versions over and over again. This is not reasonable. That's why I may solve this problem by assigning all this string into an array, and by passing this array to concatenate strings method. After iterating on the array, I may concatenate all the strings. That can be a solution. Now let's do this solution by changing these parameters to string array, say it as array, and while iterating over the array, we will concatenate all the values. Okay, s++, and say string result equals to empty string in the beginning, and while iterating over the array, we will add s array index I. Okay, and this is not s but I, and my string is result, and I will return result. Now I can push all the values into a string array and pass this array into a concatenate strings. So regardless of the length of the array, my method will do its job. Now let's go to my first app, and I will invoke it at the very end of my class, my main method. Okay, let's create an instance of string operation first, because we need to use an instance to use a class method. Okay, say it string operation and create instance by new keyword. After that, string operation dot concatenate strings. Now I need to pass a string array here, so let me create a string array. Let's say string, okay, and it is a string array that will store, say, 3 items. Okay, and I will push some values into this array. String array concatenates. The first item is Talha, second item is my surname, and third item is my job. Okay, now I will pass this string array to this method, and this method will concatenate all the values and return it. Say concatenated Hi everyone. In this chapter we will talk about constructors. Constructor is a quick setup method to initialize some attributes as soon as an instance is created. Constructor is a special method with no return value, and it is executed just after memory allocation for an instance is completed. As you know, we allocate some memory for an instance by using new keyword. And when we use new keyword, the constructor of the class is called internally. It eases our job for setting instance variable values without writing explicit lines to set them. Now let me demonstrate to you why we use constructors. Let me create a class constructor example to create some instance of human class. So I'm setting, so I want to create main method here and click finish. Now let me create a new human instance. Say human equals to new human. When I use new keyword here, some memory is allocated for this instance. But this instance is not a meaningful instance yet, because I'm assuming that for an human instance to be meaningful, it should have some values inside, weight, height, and skin color values. Otherwise, it will be a shapeless or meaningless human instance. Okay? That's why just after creating the human instance, we need to set some values to the instance variables. Say human weight equals to 65, human height equals to 180, and skin color is, say, black. Human dot skin color equals to black. If we do not assign some values to these attributes, this human instance will be somehow meaningless. To create a meaningful instance, we are writing 4 lines of code. This is a waste of lines, you know. We need to use some shorthand notation to use less lines, okay? That's why we are using constructors. We need to be able to set these values to these variables as soon as an instance is created. That's why we are using constructors. Now let me show you how to create a constructor. Most of the constructors are special methods with public accessor, and constructors are methods that do not have a return value, so I'm skipping the return value, and the name of the method is also the name of the class, so I'm writing human here, and inside the parentheses I will assign the arguments. Now as soon as creating an instance, I need to set weight, height, and skin color attributes. So my arguments are these values: weight, Hi, in this chapter we will talk about static contexts, static methods and variables. Static means beyond the instances. Till now we have dealt with variable values that created at runtime. What does that mean? We can readdress the address value of a value, and all these variables are created while the execution of the program. That's why they are called as dynamic variables. As you know, when you create a new instance of a class, a brand new memory block is allocated in heap space, and each instance context is isolated from the other instances context, so their values and method executions are isolated from each other. For instance, when you create two different instances and refer them with different references, they point to different memory blocks. But you can change the addressing value of a reference by reassigning another reference or by referring to another instance value. Okay? Here at first human and human2 was referring to different memory blocks. After that I have assigned human's address to human2's address. That's why human2 is also referring to this memory block for now. That means our variables are dynamic and their addresses may change at runtime. Java has another context called as static. Static means before the execution of the program, on class loading phase, variables are stored into class space, not to heap space but class space, and their addresses may not change throughout the execution. Since their address values are static, they are called as static variables. Here let me schematize the problem. We had a class named as human, and we had created three instances of this class: human1, human2 and human3. So they are h1, h2 and h3. And whenever we need to set a value, a variable on any instance, we are accessing this variable by dot notation on any instance. h1.weight equals to 50, h2.weight equals to 60. So they are referring to different memory blocks. This one refers to here, this one refers to here, and this one refers to here. But things are different when the variables are static. Let's say I have created a static variable on human class, say creation type. This variable is not stored on any instances, but they are directly stored in class definition space. In human class, let me create a static variable, static integer variable called as count, and this will store how many human instances we have created till now. The initial value should be 0. Now let me create another class to test static. Say static class. The name is not important, as you know, and we put the main method here. And let me create a human instance and then increment human dot count by 1, and then create another human 2, new human, and increment human dot count by 1. As you know, I have accessed a count variable not from an instance